All right, so section 1.4, we're talking about an inverse of a function, or an inverse of, they also put an inverse of a relation, okay? So we're going to put just kind of slash in brackets here, a relation. Do you remember the difference between a function and a relation? A function, if you recall, passes the vertical line test. So if you have a graph that looks like this, that's a function from what we can see from this endpoint to this endpoint. That's a function because any vertical line that we draw only passes through the graph once. So this is a function, right? Function. A relation, okay, does not have to be a function. A relation can look like this. For some reason, I don't know what kind of situation this represents, whatever the variables are, but this does not pass the vertical line test. I can draw a vertical line and it passes through the graph more than once. So this is not a function. Okay? Now we're not really studying the difference between functions and non-functions here today, but technically, if we have a relation, we can still graph its inverse. So I want to talk about an inverse of a function. So an inverse of a function. Okay. I don't know if you notice on your calculator, I'm just going to bring the calculator up on the screen here. If you look at the buttons on your calculator, oftentimes the functions on the button they'll have another function as a kind of a second function. And actually some calculators have second here, but some also have INV, okay, which means inverse. And so if we look at our calculator, look at the functions or the operations above some of these. Okay, logarithm. Above that is 10 to the power of x. X squared, okay, so a number squared. The function above that, or the operation above that, is square root. These are inverses. Sine to the -1, cos to the -1, tan to the -1. Those are inverse operations. Okay? And so when we talk about inverse, what we're talking about here is an inverse of the function is, and here's the definition from the textbook, which is sort of semi-helpful. This f to the -1, that's the notation. But when you see inverse, I want you to think reverse. Okay? Inverse means reverse. And what are we reversing? Well, when we have the inverse of a function, we're basically reversing x and y. They're switching places. Okay? So we reverse the position of x and y in the relation, or in the function. Okay? So let's see what the textbook here has to say. It says, if f is a function with a domain and a range, the inverse function, if it exists, is denoted by f to the -1. Okay, that's good. And has the domain b and the range a. So you see what they've done here? It's not the plainest of language here, but the domain, which is all possible x values, and the range, which is the y values. You see how it's switched? Okay? They've reversed. The domain and range have reversed. Really what that means is the x and the y in the explanation, or in the expression, in the equation, are reversed. So y equals 3x plus 2. Alright, let's say this is our function, f of x, okay, which in function notation you could write it as f of x or you could write it as y. They're the same thing, and the inverse of this function, and this is what you do if you have, well, okay, we're not actually there yet. Let's just do inverse, okay? Let's just erase the of x, okay? I'll explain that later. But the inverse of this function would look like this. It would look like this. X equals 3 times y plus 2. And notice how the y and the x switched places. See that? Now this is not a function right now, necessarily. It actually is. But it may not be a function, okay? Because there's a lot of original functions that when you reverse the order, it doesn't create another function. But watch this. I'm going to finish this off. And if I actually now solve for y, I can write it as in function notation. I can write it as y equals. So let's do that. Let's subtract 2 from both sides. So that's going to be x minus 2 equals 3y. Then let's divide by 3. And this is what I'm going to get. I'm going to get y equals 1 over 3x minus 2 over 3. Or if you write that the other way around, it's just, I'm going to flip that around. And this is the equation for the inverse. So now I can write f to the negative 1 of x is 1/3 x minus 2/3. Okay, now at this point I can just understand you're saying, okay, what just happened there? I have no idea what's happening right now. Let me back up. Okay, let me just back up. If this is our original function right here, f of x equals 3x plus 2, or y equals 3x plus 2, to find the inverse, think reverse. And I just simply reversed the x and the y. Just plucked them right out of there, took them right out, and I just exchanged them. And just exchange them like that, okay? And then I solved for y to get the expression of the inverse. And then I could replace this new y, really, right? This is the new y, so this is the inverse of this original function over here. So what we're going to do is we're going to graph each of these functions now. I'm going to graph the original function and the inverse. Okay, so if you want to join me here in your graphing calculator, let's graph both of these. So the first one is, you can kind of barely see it up top of the screen there, y equals 3x plus 2. So we'll go 3x plus 2 for our first function. Now the inverse we determined was this right here. So we're just going to go ahead and treat that f to the negative 1x as another y. So we'll just go down to the next line and we'll plug in this. Now you have to use your brackets probably. 1 divided by 3, that's 1/3 bracket times x. And then this is minus, I'm going to use your brackets again, probably 2 divided by 3. Okay, so that's 1/3 x minus 2/3. And then we'll graph it. Now it looks like my window is a bit funny here. But what I want you to do is to hit the zoom, okay, and I'm going to hit square. Let's hit square, number 5. Not standard, but square. So zoom. Oh, is that right? Okay. That still looks a little bit off here. Okay, just give me a second. That's standard. Okay, 10 by 10, but although the screen is kind of wonky, the scale is a bit off, right? So it should look something like that, but I'm just going to try this again. I'm going to do 5. Okay, yeah, that looks a little bit better. So do zoom 5 and see if your graph looks something like this. Any problems graphing this? Everybody's got these graphed, yeah? All right, so which one's which? Well, let's hit trace. And you see the cursor, 3x plus 2. Does that make sense that this is the line 3x plus 2? Well, a slope of 3, yeah, that's pretty steep. And an intercept of 2, yeah, here's 0, 2. That's the point that this is on right now. So if you hit your down cursor there, it goes to the other line, and this is your other line here. Okay, that's real good. So what we've done for each point is we have reversed the x and the y variables. Okay. Now, is there a point, for some reason my notes have gone, is there a point that is the same on both graphs? Oh, we may have to zoom in a bit, but there's a point right here that is the same on both graphs. You see that? What is that point there? It could be a decimal. Do you guys remember how to find intersection points? I'm just going to do that real quick here. I'm going to show you. So we've got two lines here. Watch this. Second function, trace. That's the calculate menu. Okay, go to the calculate menu. And what you're going to ask your calculator to do is calculate an intersection point. So hit number 5. And then this is what it's going to do. It's going to ask you, it says, hey, is this the first curve? And of course, by curve, they just mean line, function, whatever. And you say enter, yes. Then it's going to pop down to the next curve. And we only have 2 typed in, so that's the other one. Is this the second one? And you say yes. And then it says, do you want me to guess what the intersection point is? And you're going to hit enter once again. So it's just enter, enter, enter. And look at this. -1, -1. Does everyone get that for an intersection point? this intersection point negative 1, 1, okay, the interesting thing is these are both the same values. Now, would it make sense that that point is on both graphs? Like if you switch negative 1 with negative 1, what do you get? You get negative 1 and negative 1, right? Same as what you started on. And actually, if we do more and more of these, if we do more of these pairs, what we'll find out is the invariant points would be the points that lie on the line y equals x. So it's kind of like this imaginary line y equals x, where both the points are the same, negative 1, negative 1, negative 5, you know, 2, 2, 4, 4. That is the reflection line. Okay? Because, and I'll just show you here. Okay, I'm going to do this real quick and messy. But let's say I have, I'm going to do this line right here, this thing right here. Okay? And I'm going to make up some points here. So this is going to be about negative 5, 2. Okay? I'm just going to do a few. This is going to be, let's say this is negative 3, negative 3. And this over here is going to be, let's say 2, 0. Okay? If you want to just sketch that out quick, you can. If you want to just sit and watch, that's totally fine. It doesn't matter. But now, if I reverse these points, and of course we could reverse all the points, but if I reverse the order of x and y with these points, I'm going to get a new point. From this, I'm going to get a new point, 2, negative 5. Does everyone see that? So where's 2, negative 5? Well, that's about over here. 2, negative 5. This one is going to be what? If I reverse negative 3 and negative 3, that's going to be negative 3, negative 3. So guess what? That's the same point. All right. What about 2, 0? 2, 0 is going to become 0, 2. You see how we just reverse the order there? Okay. Inverse means reverse. And so if I were to kind of connect these lines here, it's going to be, just watch here. So it's going to kind of look like this, right? That would be what the lines, the points in between would look like. And then I'm going to kind of go like this, because this intercept would also reflect over here, right? This here. Now, if the y equals x line was this line right here, you see how this curve would kind of like meander over like this? You see? All the points, when you reverse the order, creates a graph that is actually a reflection in this line y equals x. Okay? So the inverse of a function is the graph that creates the reflection in the y equals x line. So let's just write that out for some notes here, okay? Okay, so the graph of an inverse function is the graph that is a reflection of the original about the line y equals x. So we could start off with a graph, and you could kind of sketch where that y equals x line is, and you could draw a reflection just to sketch it. Or you could reverse the variables and then solve for y again. So this is what we're dealing with when we're talking about inverse relations. Now, I should talk to you about the vertical line test. Okay, or sorry, I'm going to call it, it has to do with the vertical line test, but it's called the horizontal line test. That's what I need to talk to you about today. Horizontal line test. All right? So what is this? Well, let's say we're given a function here, or I mean a relation of some sort. Okay? So it looks something like this, okay? That's the original f of x. The horizontal line test is something that we can do to determine whether the inverse is a function or not. Okay? So if I draw a horizontal line, you know how we drew a vertical line to test if something was a function? Well, the horizontal line test, let me do that again. Okay, the horizontal line test, this helps us to determine if the inverse is a relation. So if a horizontal line passes through the graph more than once, then we know that its inverse will not be a function. So just like a vertical line test tests whether a relation is a function or not, the horizontal line test tells us whether its inverse will be a function or not. You know, it's just easier than actually kind of trying to really quickly, map out the reflection. So if we did this, right? So we've got something like this. This goes over here. This goes up there. There's a point here. And so instead of doing this, I'm going to actually sketch this out here. And then testing a vertical line test. Oh, it's not a function. See that? Well, you could have just done a horizontal line test on the original line to find that out. So that's what that is. Okay? Horizontal line test. All right? Now, so graphs can be kind of funny, right? They can look kind of funny. They kind of get some interesting designs there. On your graphing calculator, you cannot graph all inverses. If they're not functions, you can't graph them. Your graphing calculator will only graph functions. But what we can see is that you can get around it. You can graph two parts of the function, right? Or two parts of the relation to make it look like a whole function. But let's just do a real quick example of a parabola. So I'm just going to go back to the textbook here and get the page. Let's see. Well, there's an interesting diagram. Right here. Okay, so this is in your textbook. Here's a parabola. All right, it's got its vertex there now at -2 is x squared minus 2. The inverse, okay, so the inverse of the point, let's just look at the graph first, then we'll look at the equation. But the inverse would be where every point, x and y, is reversed. So on the inverse, it would be y-axis, right? Here's your y equals x line. And it's maybe a bit difficult to see, but every point, like let's say this one right here, this point right here, 0, -2, has its partner point, -2, 0, right over here. This one, -1, -1, is an invariant point. It's right on the line. It stays on the line. But these other points, like this one here, -2, +2, well, that becomes +2, -2. You connect these points. Do you see how this inverse is not a function? See, in red? So that's what the inverse looks like. So what does this red function, the inverse of f of x, what does it look like if we're you're looking at the equation? Okay? Syncing issues here. So that's, what was that? Y equals x squared minus 2. Okay, so inverse is going to be x equals y squared minus 2. And now I have to get y by itself. So let's do this. Let's add 2 to both sides. Right? And then let's square root both sides. When we take the square root, guys, of something, you have to remember that really it could be plus or minus. Plus or minus the square root, right? So this would become y equals plus or minus the square root of x plus 2. This is the equation of the inverse right here. Now what does this plus or minus mean? Well, we just draw a quick sketch of this. Okay. So it maybe looks something like this. Okay, kind of terrible, but yeah, it's bad. Okay, anyway, so here's your y equals x line. We've got an invariant point there. We should have an invariant point there. But what this means is that from here up, like right here, this is going to be your positive version for the positive part. And then this right here underneath is going to be the negative part. So it's kind of like two parts of the inverse. Okay, so if we graph that, let's take a look at what it looks like. I'm going to clear those out. So let's graph y equals x squared plus 2 first. X squared, or minus 2, sorry. Let's do that one. And then we're going to graph this positive version of the square root of x plus 2. So let's just see what those look like here. There's the parabola, and there is the top part of the inverse, see? That's the positive part. Now if we go back to y equals, and I do the negative version of that, x plus 2, I'm going to get the bottom half graphed out. So I wasn't that far off my diagram. And if I zoom in there, let's just do zoom in, zoom to. Okay, so there's that. There's the positive part, and here's the negative part. Good? Got it? Okay. So inverse, think reverse. Inverse, think reverse. The summary of this lesson from the textbook, these key ideas are right here. I'll just give you a second to kind of read through those, and I'll give you your assignment. Yeah, zoom to is zoom in, and then enter. Yeah, yeah, because there's a little cursor that's blinking there, and you can move that cursor around to where you want the center of your screen to zoom into. So if you just want it to zoom into 0, 0, then just hit enter. If you want to move that center of that zoomed in screen, then you just move the cursor. Yeah, you bet. Okay, questions for your assignment 1, 2, 3, 4, 5 AC, 6, 11, 13 AC. This is the last section in your chapter, so that means we're going to have chapter tests coming up pretty quick here.